This is the final lesson in our reactions and stoichiometry unit. This lesson will cover success criteria C and D on the final learning goal, the 5.3 classifying reactions. Our success criteria for this video are success criterion C, I can predict the type of reaction that will occur, and success criterion D, I can predict the products of a reaction. So from the previous lesson, we learned about the 5 different reaction types: single displacement, double displacement, synthesis, decomposition, and combustion. And we looked at patterns and how we could recognize each of those reaction types given the entire equation. What we're going to start looking at here is if we're simply given the reactants, so you're not going to be given any products here, simply given the reactants, if we can identify those patterns, if we can recognize the patterns of the reaction type, we can predict the type of reaction that will occur simply based on the reactants of the reaction that we are given. Now, like we talked about in the last video, there are all sorts of different chemical reactions that would not fit neatly into these particular categories, but for our purposes and the ones that I will give you as examples and homework and all that stuff, each of them will fit into the categories that we have learned. Alright, so let's jump into what this would look like. So I'm just asking you, what type of reaction would we predict would happen? So for each of these, I will give you just the reactants, and from our knowledge of reaction types, we'll be able to come up with what type of reaction should occur. So this first one here, the only reactant is the sodium oxide, the Na2O. Based on the fact that there's just a single reactant, that tells us what this is going to be. So think about that. If we just have a single reactant, that means it can only break apart into 2 or more products. That's all that can happen. So that would be decomposition. Now, in this particular slide, we're not going to actually write the formulas of the products. We'll do that on the next slide. But what we would see is this would break into sodium and oxygen. Like I said, we'll hit that up on the next slide, what that would look like. So here's the next one. So we have CuCl2, the copper 2 chloride, reacting with Na3PO4, which is sodium phosphate. So take a look at those reactants. Based on the patterns we identified from the last lesson, ask yourself, what's going to happen there? How are those compounds going to react to give us products? Well, here's the giveaway. If we have 2 ionic compounds reacting, and recall ionic compounds just means we have a cation and an anion, a positive and a negative ion. So we have a cation that's copper, an anion that's chlorine, a cation that's sodium, an anion that's the phosphate ion. That will allow the ions to exchange. Well, that's a double displacement reaction. What happened here, the copper and the sodium would just switch partners, if you will, and the copper would go with the phosphate, the sodium would go with the chlorine, so that would be double displacement. Let's look at the next one, potassium reacting with chlorine. Well, notice here we just have 2 free elements. I don't have any compounds. Potassium is a free element, chlorine is a free element. Recall when we use the term free element, that just means that the elements are not in a compound with something else. So the only thing they can do is combine and form a single product. Well, that would be synthesis. These 2 will combine and give us just the one product. Alright, next one, C2H6 reacting with O2. Here the giveaway is the fact that oxygen is a reactant. Recall from our last lesson, anytime oxygen is a reactant, that means we have combustion. And then finally, our last example is copper 2 chloride, the CuCl2, reacting with zinc. Now do recognize this, that these reactants here look very similar, at least as far as a pattern, to the last example. And I did this in this particular order so we can see this. Oftentimes students will confuse this combustion reaction with what we're going to classify here. So here the giveaway is we have a free element, zinc, reacting with an ionic compound, the copper 2 chloride, the CuCl2, which you could say something similar about this reaction here. We have a free element, oxygen, reacting with a compound. Now this one here isn't ionic because they're both nonmetals, so that's not really our concern here. But they look similar, and so you might say, well, why aren't these two going to be the same? Well, the key here is in the previous example, if O2 is a reactant, that means we have to have combustion. End of story. There's no other conversation to have. Here, our free element is not oxygen. So anytime we have this, a free element reacting with a compound, we are going to have single displacement, where the free element zinc will take the place of one of these elements. In fact, it will be the copper, because they're both metals. The zinc would take the place of the copper would get kicked out by itself, and we'd get our products. So as long as we can recognize the patterns of the different reaction types, we should be able to predict which type of reaction would occur. So let's take this a step further now and ask ourselves, how do I figure out the products? So I'm going to give you the exact same reactants we had on the last slide, and I'll just give you those reaction types that we determined, and then we will now write the formulas of the products that we'll get for each reaction. So the first one we looked at on the last slide was this decomposition reaction, Na2O. Now recall, decomposition just means the reactant, and there's just one of them, will break apart into two or more products. Well, the fact that there's just two elements here gives us only one option. It's going to break apart into sodium and oxygen. Now you may be wondering, why O2? Well, you just have to remember that oxygen is diatomic, thus that's what its formula is. So for any free element, and this isn't just for oxygen, for any free element, you want to ask yourself, is it diatomic? Recall, there are 7 diatomic elements. 6 of those 7 form that number 7 that looks like the number 7 on the periodic table. You guys have marked these on your periodic tables, and if you haven't done so, or if you've gotten a new periodic table and you need to mark them again, please do. Remember, the diatomic elements are nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Notice how those 6, nitrogen over to fluorine, then down to iodine, those make the number 7, and then the 7th is hydrogen. So those 7, if they are free elements, meaning if they're by themselves, it's a 2-atom molecule. So O2, F2, Br2, H2, etc. All right, let's take a look at the next one. So the next one we decided was double displacement, the reaction between copper 2 chloride and sodium phosphate. So recall, what that means is the ions will just exchange partners. So the copper, the cation in this compound, will take the place of the cation, the sodium, in the other compound, and vice versa. So our products here, and you may be looking at those formulas now saying, well, wait, how the heck do we get those formulas? And I'll show you here in a second. But the copper is now with the phosphate. We can see that here with the Cu3PO42. And the sodium is now with the chlorine, thus we have NaCl. Now about those formulas, you have to write the formulas just like you learned how to do when we learned about nomenclature. Recall that the total charge of any ionic compound has to add up to 0. The charges must cancel. So when I write these formulas, I can't just write CuPO4 because that's what I see on the left side. I have to consider the charges. So recall that the copper ion, I can see it here. The charge on the copper ion is 2+ on the reactant side. I know that because there's 2 chloride ions and each chloride is 1-. So the copper is 2+. The phosphate is 3-. You can see that on your polyatomic ion chart. So in order to get the formula for the charges to cancel, I need 3 coppers, so Cu3, and I need 2 of these phosphate ions, so PO42. Same story with the sodium chloride. I can't just write Na3Cl2 because those are the subscripts I see on the left side. I have to consider the charges. The sodium is 1+, the chloride is 1-, so NaCl. All right, let's take a look at the next one. Synthesis of potassium reacting with chlorine. And again, I knew this was synthesis because we just had the 2 free elements, so that will just give us potassium chloride, KCl. Again, you have to consider the charges. The potassium is 1+, the chloride is 1-, so thus just KCl. Again, it is not KCl2, just because I can't just look at these subscripts. Now, one thing you might notice is these equations that I have written so far, these are not balanced. Okay, so if we wanted to write a balanced equation, once we have our product formulas written, we would then need to go back and balance the equations like you all know how to do at this point. So in other words, when we write the formulas of the products, you don't write the formulas to balance the equations. You write the formulas correctly, and then if we need a balanced equation, we go back and balance it. All right, let's look at the next one. So the next one we decided was combustion. And recall with combustion that we simply get oxides of the elements that are in the compound being burned. So in this case, we'll get carbon dioxide because I get an oxide of carbon, and the most common oxide of that is carbon dioxide, so CO2. And we get an oxide of hydrogen. The most common oxide of that is water. Okay, so anytime we have combustion, combustion will produce oxides of the elements that are being burned. And then the last one we said was single displacement. And recall with single displacement, the free element, in this case our free element is zinc, it will take the place of the element that will form the like charge that it would in the compound. Well, zinc is a metal, meaning it will form a cation, positive charge, so it will take the place of the cation in the compound, which is copper. I know that because it comes first. And so my products are zinc chloride, the ZnCl2, and the copper. Now recall, we still have to think about formulas. Or charges. It just so happens to work out here that all my subscripts are the same. That's just because the charge of the zinc is the same as the copper. The copper here is 2+. I can tell that because there's 2 chlorides and each one is 1-. The charge on a zinc ion is also 2+. Okay, so that means notice I have a 2+ for the zinc and 1- for the chlorine, so a ZnCl2. So the reason we knew the zinc would replace the chlorine replace the copper, is because the zinc will form a cation, a positive charge, so it will replace the cation in the compound, which is copper. And then the copper just gets kicked out by itself. And recall the question you want to ask yourself with any free element is that element diatomic? And copper is not, so it's just Cu. Alright, so now we're going to put it all together where I'm going to give you the reactants for a reaction, and you will need to predict the products, but in order to do that, you need to ask yourself first what type of reaction is likely to occur here. So this first one, we have sodium oxide reacting with fluorine. So look at that, pause the video, ask yourself what type of reaction is likely to occur, then write the formula of the products. Alright, so you've had a chance to think about that. So this will be single displacement. We know this because we have a free element, fluorine, reacting with a compound. So the fluorine will take the place of the like charged element. Well, fluorine is a nonmetal, meaning it will gain electrons. It will form an anion. So it will take the place of the anion, the negative ion in the compound. So that's oxygen. So the fluorine takes the place of the oxygen. The oxygen gets kicked out by itself. And so that will give us sodium fluoride, which is NaF, and again you have to think about charges. The sodium's 1+, the fluoride's 1-, so just NaF, and then we also get O2, and again it's O2 because oxygen is diatomic, so not just O but O2. Alright, next one, KF. So again, pause the video, ask yourself what type of reaction, what will the products be? Alright, the fact that we have just a single reactant tells us it has to be decomposition, meaning this compound will just break apart, and the fact that there are 2 elements there, it will just break apart into two free elements, so I'll get potassium and fluorine. And again, recognize fluorine is diatomic. Anytime we have a free element, always ask yourself that. Fluorine is diatomic, so F2, potassium is not, so it's just K. And again, recall, these equations that we have written at this point, these are not balanced. If we needed to write balanced equations, we could go back and do that. But every year, and I certainly understand the confusion, students will look at this and say, well, shouldn't it just be K plus F because that balances the equation? We don't do that because we have to write the formulas correctly first. Now, these are the correct formulas. Once we've done that, we could go back and balance the equation if we needed a balanced equation. Next one. We have magnesium hydroxide reacting with phosphoric acid. So again, pause the video, ask yourself what type of reaction and what will our products be. So this one would be double displacement. I know that because I have 2 ionic compounds, okay, 2 compounds, cation, anion, cation, anion. So the cations are just going to exchange partners. So that's going to give us magnesium phosphate. Notice the magnesium is now with the phosphorus, the phosphate ion, and the hydrogen is now with the hydroxide. I know it doesn't look like that. We see this H2O here, but I'll show you how we get that here. So again, we have to think about charges. I can't just write MgPO4 because that's not likely to be the correct formula. The charge on a magnesium ion is 2+. The phosphate ion is 3-, so I need 3 magnesiums and 2 phosphates, so thus Mg3PO4 And then for the other compound, I get a hydroxide ion, which is 1-. Hydrogen is 1+, so that's HOH. Well, we don't write it like HOH. We just write H2O. That's our formula for water. So that's how we get that. All right, next one. We have potassium reacting with oxygen. Pause the video. Ask yourself what type of reaction. What are the products going to be? So this one, actually, we can categorize as 2 different reaction types. Either way, we're going to get the same products. It's synthesis because we just have 2 free elements, so the only thing they can really do is combine and form one compound. It's also combustion because we have O2 as a reactant. But either way, you're going to get K2O as a product. Notice it is just one product because it's synthesis, and it's combustion. That means we will get an oxide of the elements being burned, so we get potassium oxide. Again, you have to consider the charges. Potassium is 1+, the oxide ion is 2-, so thus K2O is our formula. And the last example here, we have C10H22 reacting with O2. Pause the video, ask yourself what type of reaction you would predict. So this one, like the last one, is combustion because we have O2 as a reactant. Now this one's not synthesis because we have a compound, not an element being burned. And so remember, we always get oxides of the elements. So we'll get an oxide of carbon, well that will be carbon dioxide, CO2. And we'll get an oxide of hydrogen, which is water, H2O. And so that's how we get our products there. All right, looking at our learning goal and success criteria. This was the second of 2 videos on Learning Goal 5.3, understanding how reactions are classified. And in this video, we looked at how we can predict the type of reactions that will occur, that is success criterion C. And we took a look at predicting the products of reactions, and that was success criterion letter D.